Good day everyone, I am Emeline Espanta. I am a BSE student from Eastern Visayas State University Ormoc City campus, and I was tasked by our instructor, Engineer Jericho James Agapito, to discuss and explain the answers and solutions for quiz number 1 in electrical apparatus and devices. So we are given two problems. The first problem states that the maximum flux in the core of a 3500 300 volts 60 Hz single phase distribution transformer is 300 Weber. If the voltage induced per turn is 8 volts and the cross-sectional area of the core is 500 centimeters squared, so we have to determine the following. The first one to be determined is the flux density in the core. The second one is the turns in the secondary side. And lastly, the voltage induced per turn in secondary side. So before we jump into our solution, we should be able to collect the given, or it's better to write first the given. So we have here the primary voltage, which we have 3500 volts. The secondary voltage is 300 volts. The frequency given is 60 Hertz. And also the maximum flux in the core is 300 Weber. The voltage induced per turn is 8 volts. And lastly, the cross-sectional area is equal to 500 centimeters squared. So in our solution, by the way, the given cross-sectional area, 500 centimeters squared, actually, centimeters squared is not equal to squared centimeter unless the value of that centimeter squared is 1, then it is equal to 1 square centimeter. Why? Because the centimeter squared means dimension. Before we can obtain the area, it is actually an area, a dimension. So 500, before getting the area, we have to raise 500 into square. So we have 500 squared, which is 250,000 square centimeter. So that in that case, it will be an area na. And then, so proceeding on our solution, we know that since we have converted the 500 centimeters squared, which is raised to 2, we have 250,000 square centimeter. So it is square centimeter. And then we know that 1 square centimeter is equal to 0.0001 square meter, or 1 square meter is equal to 10,000 square centimeters. So before we could obtain that, we have to convert the square centimeter into square meters. So the formula for the flux density is equal to flux over area. So the unit for our flux above should be Weber, and then over the area, which is the unit for area, is square meter. That is why we have to convert 250,000 square centimeter into meters to obtain the area in square meters. So we have 250,000 square centimeter times 0.0001 square meter over 1 square centimeter. So we have 25 square meters. So by substituting the this to the equation, we already have the value for our maximum flux in the core, which is 300 Weber, and the area, which is 25 square meter. So we have to divide 300 Weber over 25 square meters. So we have obtained the value for our flux density is 12 Tesla. So the unit for flux density is Tesla. Proceeding on letter B, we are tasked to find the number of turns on the secondary side. So we have a given of the induced voltage, which is induced voltage per turn, which is 8 volts. So since assuming that we already have studied the book that was referred by Engineer Agapito, our instructor, that so I won't explain some details now. So we have here an equation. We have the primary voltage over secondary voltage is equal to the primary turns over the secondary turns. And then using cross multiplication, I was able to obtain the primary voltage over primary turns is equal to the secondary voltage over the secondary turns. So since the induced voltage per turn is 8 volts, so this we have 8 volts. I put 8 volts here, and then is equal to 300. 300 is the secondary voltage over the secondary turns, which is the unknown. So since using cross multiplication to simplify, to separate the unknown variable to the left side and to combine the known variables on the right side. So I was able to obtain this variable, or the secondary turns, is equal to 300 over 8. So by simplifying, I was able to obtain the value for the secondary turns, which is 37.5 or 38 turns. So that is the answer for letter B. So proceeding on letter C, we were asked to determine the value of the induced voltage in the secondary per turn in the secondary side. Since we already have the value of our secondary turns, it would be easier for us to obtain directly the value of the induced voltage on the secondary side. So we have Vs over Ns is equal to, we already have the value for our secondary voltage, which is 300 over the value of the secondary turns. So I actually use the 37.5. So by 300 over 37.5, I was able to obtain 8 volts. So the induced voltage on the secondary side per turn is 8 volts, the same on the primary. So let's proceed to the next problem. The problem states that the net cross section of a transformer is 20 inches square, and the maximum flux density is 11 kilogauss. The frequency is 60 hertz. If there are 1000 turns in the primary, what is the primary induced EMF? So again, we need to put the given for us to have an easier way in solving the problem. So we have 20 inches square. You have noticed that it is inches square instead of square inches. Please be reminded that inches square is not equal to square inches unless it is 1, because inches square is actually a dimension. So in order to have it on a square inches, we have to raise 20 by 2. So, and then we have a given flux density, which is 11 kilogauss, and we have a frequency which is 60 hertz, and the primary turns we have 1000 turns. We were asked to find the value of the primary induced EMF. So first, in our solution, as what I've said earlier, that the 20 inches square is a dimension, and before we could use it as an area, we have to raise it into 2 to have it on square inches. So 20 squared is equal to 400 square inches. So from what I've said, that the area should be in square meter. So since we already have square inches, we have to convert it first into square centimeters. So we have 400 square inch. By the way, 1 square inch is equal to 0.000645 square meters. And then, so proceeding, we have 400 square inches times 0.000645 square meters over 1 square inch. So we have to cancel the square inch both sides. So we obtained 0.258 square meters. So we have a given which is 11 kilogauss, which is equal to 11,000 gausses. Please note that 1 gauss is equal to 0.0001 Weber per square meter. So we have to convert 11 kilogausses into Weber per square meter. We have 11,000 gausses divided by 1,000 is equal to 1.1 Weber per square meter. So we already have this. But then we have the area in this one and this one. So we have to multiply those to cancel out the square meters. So we have 0.258 square meter times 1.1 Weber over square meters. So cancel out. We were left with Weber, a unit of Weber. 0.258 times 1.1 Weber is equal to 0.2838 Weber. We have the formula. We are given with the formula, which is EMF is equal to 4.44 times N, which is the number of turns, times F, which is the frequency, the flux, the maximum flux. So this one we already obtained. The unit for this one is in Weber. So we have obtained that the Weber, or the maximum flux, is equal to 0.2838 Weber. Since we already have the values for each variable, we can substitute it to our equation to obtain the value for our EMF. So in the induced EMF on the primary side. So we have 4.44 times 1000 turns times 60 hertz and times 0.2838 Weber. So we have obtained the value for our induced EMF in the primary side, which is 75,604.32 volts. So that is the answer. So that would be all. Thank you.